Hello and welcome to this second tutorial on discrete time signal processing in MATLAB. So we define a signal in MATLAB using two variables. So where this variable n is used to specify the time indexes where the signal has non-zero amplitudes, as you can see here, and this variable x is used to specify the amplitudes for each of these time indexes. So when you perform shift, there can be two different shift operations, the shift right operation or the shift left operation. So in case of shift right operation, the signal uh, is moves towards right by a specific amount of samples, right? So x of n minus n naught means we need to move our signal towards right uh, by n naught samples, right? So n naught is the number of samples by which we need to uh, shift our signals, right? Similarly, in this case, a signal moves towards left, and um, it can be specified using this plus operator, which means the direction of shift is towards right. So n naught again is the number of sample shift towards right, left, right? So so when you look at this particular operations, so here n naught is equal to 2. So we need to shift this particular signal by two samples, and the shifted signal looks like this. Whereas you can see, apparently there are the time index seems to have changed. The In this case, the non-zero amplitudes start at time index -2, and they continue till time index 3. But here, the starting point of the non-zero amplitudes is 0. So it's basically you have added, it seems we have added 2 to this amplitude axis, or right, and um, and now once it starts from 0, it goes till 5. So we seems to have extended our time index, right? And similarly, in case of shift left, um, we seems to have, and in this case we have a shift left by a sample of 2 again, right? So we seems to have added -2 to this original time index, where originally the time index of non-zero sample started at -2, but now it is starting at -4. And originally the time index of non-zero samples ends at 3, but and in this shift left shifted signal, the signal is ending, or non-zero samples are ending at time index 1, right? So now let's see how we can perform this shift operation in MATLAB. So I've already defined the signal in MATLAB using these two variables n and x. So n contains the amplitudes, the time indexes, and x contains the corresponding amplitudes. So I've also plotted the signal using this stem option, which basically gives us uh, a way to plot discrete signals as stems on specified time indexes, right? So now let's see how we can perform the shift operation. So to see how we can do that, let's go back to the tutorial. And if you look at it, effectively the shift operation uh, is changing the time index variable only. The amplitudes are same. Like this amplitude variable, as you can see, remains the same, uh, but time indexes are changing, and the non-zero amplitudes have now shifted to this new starting point, that is 0, and this new ending point, that is 5. And as you can see, the shift or the change in this original time index variable is the addition of 2 in this in the original one, right? So if you add 2 in this original time index variable n, so the starting point will become 0 and ending point will become 5, right? So let's do that. So in its simplest form, the shift operation is just an addition uh, in the addition of number of samples uh, in the original uh, time index variable, right? So let's add 2 because we are shifting our signal by 2 towards right. Okay. Uh, so we get this new time index variable n1 there, which starts from 0 and it's ending at 5, right? So since amplitudes are same even after the shift, so we don't change the amplitude variable, right? So let's plot it. So we change now specify the new time index, and the amplitude variable remains the same. So, and to keep the previous plot, I use this figure option with the new plot, right? So let's compare the two. So figure 1 contains the original signal and the figure 2 contains the new signal, right? So as you can see, the original signal is starting from -2 and going till 3, and the shifted signal is starting at 0 time value at time 0 and going till 5, right? So this is the simplest way to perform right shift operation, right? And similarly, in the left shift operation, we need to subtract my 2 from the original time index. As you can see, shift towards left by 2 requires uh, subtraction of 2 from this variable, that variable n or the vector n, that would make the initial point -4 and final point 1, right? As you can see here. So in this particular case, uh, the time index, the new time index starts from -4 and ends at 1. So to do that, let's define this new uh, time index variable n2, right? And it basically requires us to subtract 2 from the original time index variable, and we get this new time index variable n2, right, which starts from -4 and ends at 1. And to plot this shifted signal, so now shift the signals that is shifted towards left is can be is specified using the time index variable n2 and the amplitude variable x, right? Okay, so as you can see, this new shifted signal towards left is, and let's compare it with the original signal, and the original signal is starting from -2, and this new signal is starting at -4, this signal that is shifted towards left, and this signal, original signal, is ending at 3, and the signal that is shifted towards left is ending at 1. So this is how you can perform the shift operation in its simplest form, towards left or right. Although we have performed shift operation on MATLAB, but the visualization of the shift can be improved, because as you can see, uh, for better visualization, we can keep the initial point of the new time index as it is, and we can extend the time index towards right by 2 samples. Okay, and we also need to change the uh, amplitude variable x by padding 2 zeros towards left side, or on the left side of the variable. So let's do that. So so we are now trying to evolve the right shift operation, and in order to do that, we are redefining the time index variable. So we keep the starting point of the original time index as it is. So we take the starting point of the variable n, which is the first starting point of the vector or variable n, is the first index of n. So we take n1, and then we take the final point, which can be obtained using this keyword end in the argument uh, parenthesis. So this keyword end provides you the final point of any vector, right? And then you, to extend this towards right, we add 2 in the final point, right? And so now we have provided a starting point for the new index, which is as same as the starting point of the original time index, and this new final point, which is addition of the amount of shift in the final point. So the amount of shift is 2, and the final point is n of end, which is the final point of n, which is 3, right? So once you press enter, you get this new time index n1, as you can see here. So it is starting from -2 and it is going till 5, right? Now we need to append 0 uh, on the in the amplitude variable. So we name the new amplitude variable as x dash, and we concatenate two zeros on the left side. So to concatenate two zeros, we use this function zeros, and we define a row. And that the reason why I define a row is because I know the x is a row variable, as you can see here. So to concatenate two zeros, I need to define a row variable, a row vector of two zeros. And in case if this x was a column vector, then I would need to define this as a column vector of two zeros, and concatenate vertically. To concatenate vertically, you need this operator, but to concatenate horizontally, you need row operators. So we keep it as it is because both of these are row vectors. And now this is our new amplitude variable, right? Okay, so now let's plot it using stem option. So let's we can type. So always use the figure option to keep the previous plots, and 1 is the new time index, and x dash is the new uh, amplitude variable of the right shifted signal. Okay, so just press enter, and you will see this is as you can see much better visualization of the shift. As you can see, this shift is of two samples, and you can see the two samples on two zeros on the first 2 points, and also the shifted signal towards right. Okay, similarly we can evolve the left shift idea as well by defining a new uh, time index n2. So in order to evolve this left shift idea, we need to see that we need to extend this time index towards left. To extend the time index towards left, we need to change the starting point. So we need to subtract 2 in the starting point. So originally the starting point is -2, and to extend it towards left, we need to add, or rather subtract 2 from the starting point, that is -2, and we also need to change the amplitude axis by concatenating two zeros on the right side. Okay, so let's do that. So n2 is so we need to, since we need to add -2 on the starting point, so rather subtract 2 or add -2, it doesn't matter, whichever way you say it. And we keep the ending point as it is, because we are extending the axis towards left. So we don't change the endpoint, we only change the starting point. Okay, and so we have defined this new time index variable, and we define the new x or rather x dash dash कर लेते हैं, x dash dash, right? So x dash dash is now, here we need to depend zeros on the left side rather on the right side. So again, since x is a row vector, I define a row vector of two zeros. Uh, in case the x was a column vector, I would be required to define a column vector of two zeros, right? So x dash dash is equal to, now this new amplitude is x dash dash contains the new shifted amplitudes towards left, and now let's plot it. So to plot it, we use this previous command, and we make x dash as x dash dash, and n1 to, we change n1 to n2. Okay, as you can see, this is the shifted signal. It's starting from -4, and we see these two zeros on the right side as well. So as you can see, this is much better visualization of shift, right? Okay, so now that we have learned to perform shift operation in MATLAB, let's make a function for it. So to make a function, we write this keyword function, and we specify the name of the function, sig shift in this case, and we specify the input arguments. So input arguments would be the signal, the original signal that we want to shift, and the amount of shift. So the original signal, we specify a signal in MATLAB using two variables, that is time index and the amplitude variable, and n naught specifies the shift, amount of shift, right? And the output would be the new time index, which let's call it n1, and the new uh, amplitude index, let's call it x1, right? So to make it generic, we need to first check whether the shift is left or right. So um, so that can be easily checked by using this if statement, where we need to check whether n naught is negative or positive. So if n naught is negative, it means the shift, we need to perform left shift operation, and if n naught is positive, which that means we need to perform right shift of right shift operation. So if this if statement is true, we need to write, it means that n naught is negative, and now here we need to write code for left shift operation, right? So in left shift operation, we define this new variable n1 by extending the previous time index towards left. And in order to do that, we add, rather we subtract this, sorry, we add this n naught in the starting point. So 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 starting point of n is n of 1, and we have added n naught in n of 1. So since n naught, we know n naught is negative, so when we add n naught in n1, it means we are actually subtracting the amount of shift from the starting point, right? So that means extension of the axis, time axis, towards left. And here we specify the endpoint, n of n. So we've specified the time index and of the shifted signal, left shifted signal, and now we need to specify the amplitude variable. So in amplitude, in case of left shift, we concatenate zeros towards uh, uh, right. So we say that is concatenate n naught zeros on the left side of the row vector x, and we do that using this uh, this uh, this built-in function in MATLAB that gives us as many zeros as we want, right? So that's it. And now we use this else command. So in this else command means now that if this if statement is not true, then uh, this means n naught is positive, and that means we get to perform right shift operation. And in case of right shift operation, we need to define n1 again. So in case of right shift, so we need to extend the time axis towards right. That means we keep the starting point of the original time index as it is and get to add n naught in the endpoint of the original time index, right? So since we know that n naught is positive, so when we add n naught in the endpoint of n, that means that the new axis will start from the starting point of the original axis but will be extended by n naught samples towards right. Okay, and now we define the new new amplitude variable that requires concatenation of zeros towards left of x, right? So how many zeros we need? We need n naught zeros. So we define a row vector of n naught zeros using the zeros function in MATLAB, and we concatenate it on towards left of x to get this new amplitude variable, and that's it, right? And I think that's it. This is more or less it. And now if we need to save this function, I guess. So we save it. So we save it by the same name that we have given to the function. Uh, and now let's run it. So I guess we have already defined x n and x, and we need to define n naught. So let's say n naught is 2. So and now let's also plot it within this function, right? So let's temp. Maybe you can later comment it, but to see the result of shift operation, let's plot it. So stem n comma x. This is the original signal. Figure and this is the shifted signal. Okay, and uh, now let's run it. Right. So I took n naught to be 2. So I took n naught to be 2. That means n naught is positive, which means we are shifting towards uh, right. And as you can see, the resulting output n1 and x1 is uh, where n1 is shown here, where n1 is extended towards right, and x1 contains these two zero paddings, right? And in case n naught is -2, the result is okay. So we received this error, and let's see what could be the error. And let's go to the code. Okay, so the error is in the x is not same as y. In case of positive shift, there is no error, but in case of negative shift, there is error, and it says that n1 and x1 are not of same length. In MATLAB, in order to plot them using the stem function, these two should have same length, right? And oh yes, the reason, I think this is the reason is that okay, so n naught is negative, and when we are asking MATLAB to produce a vector of n naught length, a vector of zeros of length n naught, um, basically this function will not work because n naught is negative, and MATLAB cannot produce minus a vector of minus two zeros. So we need to, in this case, we need to write here absolute function, which means we need to make it positive. I think this in this time it will work. Yes, it does. It works now. So this is your function to shift in both directions. This is a generic function. You just need to specify a not. It will give you shift in both directions. Okay, thank you very much. And by the way, this is how you can see the result.